That's all those things you got to consider when you're looking for a job. Is yeah, it pays more, but can you afford to live there even with the more pay? Okay, so now it's time to get to our circles. The bridge between polygons and circles is really kind of natural. If I have a polygon, we start out with a triangle. We go to quadrilateral, pentagon, if I could draw better, hexagon. Each time I add a side, it gets closer and closer to a circle. And a circle, if we're dealing with calculus, becomes a polygon with an infinite number of sides. And that's actually how they find, one of the ways of defining pi is to find the perimeter of that is you take like an inscribed polygon, right, inscribe a hexagon. Oops, come on. You inscribe a hexagon on the inside. That's called inscribed if you put the vertices on the inside. Circumscribed means you'd put it on the outside like this. So now the circle is inside the polygon, inside the hexagon. Well, obviously the red one on the outside, circumscribing the circle, is bigger than the blue one on the inside. So now as I go up to 7 sides and 8 sides and 9 sides, the outside one's always bigger, but they get closer and closer to the same as far as the perimeter of them. And so that perimeter comes to a limit, and that limit is pi. So anyway, let's look at these circles and some of our features of circles. We looked at some of the features of a circle last semester. Of course, the main feature of a circle is the distance from the center to the outer edge, which is called the radius. And that is the absolute main feature of a circle. Another feature of a circle is a segment that connects 2 points on the outside edge of the circle. That is called a what? A chord. A chord that contains the center of the circle is called a diameter. A lot of people think of a diameter as being defined as 2 radii. It's really not. It is defined as a chord that contains the center of the circle. Now, the length of the diameter is going to equal 2 times the length of the radius, or to put it in abbreviations, d equals 2r. The distance around a circle is called what? Circumference. The circumference, c, is equal to pi times the diameter. Pi is defined to be the ratio of circumference divided by diameter. So pi times diameter is the circumference. Or 2 times pi times the radius. 2 times the radius is equal to the diameter, so 2r instead of d. Well, those are the basics. We also talked about a pi wedge, which is called a sector. And the size of that sector is determined by the radius of the circle and this angle here, which is called a central angle. It's called a central angle because its vertex is at the center of the circle. It cuts out a piece of the circle, which is called what? An arc. If I construct a chord, this piece of the circle that is sliced off by that chord is called a segment. Those are all ones we've seen before as well. What's that? The segment is the green part. Yeah, the chord is this boundary here. The part that's cut off, if I were actually to cut along that chord, this little piece here that falls off would be the segment. So you can remember when we found the segment area last semester, what we had to do, we had to know this central angle, we had to know the radius, and we used that to find the area of the whole sector here. Find this whole area of the sector, right? And then we found the area of this triangle and subtracted, and what was left was that segment out there. From this arc over here, I can come back here like this. I'll try that again. This is what is called an inscribed angle. So a central angle, its vertex is at the center of the circle. An inscribed angle, its vertex is on the circle. There is a relationship between these central angles and these inscribed angles. So let's say here I have this central angle at 60 degrees. If I have an inscribed angle out here on the same arc, this arc would be called a 60-degree arc because it is cut by a 60-degree central angle. So the length of that arc then is determined by that angle and then whatever the radius or diameter of the circle is. This inscribed angle up here is going to be half of the arc. So that's a 60-degree arc. That becomes a 30-degree inscribed angle. We're going to look at those a lot more in the next couple of days. If we have a line that touches the circle but does not penetrate the circle, that is called a tangent. Very good. If I have a chord that cuts through the circle or a line that cuts through the circle, it is called a secant. A secant contains the chord, but it continues. A secant is technically defined to be a line or a segment that is part inside and part outside of the circle. Now this next piece is a little unusual. Not a lot of textbooks actually define this. This is something called a reference diameter. The reference diameter is just the horizontal diameter across the circle, in most cases. Sometimes we do a little bit of a switch. We start talking about complementaries, and the reference diameter becomes the vertical diameter. But for the most part, the reference diameter is the horizontal diameter. Now, based on that, we're going to define something called a sine. The sine is a distance from any point on the circle to the reference diameter. So what does that mean? Well, for this point right here, I measure its distance to the reference diameter. That distance is its sine. Now remember, distance is always measured on a perpendicular. So that's at a right angle there. So this point here is going to have a different sine. That length is the sine of that point. This point here has a shorter sine because it's closer to that diameter. Every point on the circle has a unique sine. Well, I shouldn't say every point because there'll be a point right here that has the same sign as this one over here did, right? But that's what a sign really is a distance from a point on the circle to that reference diameter. So let's say we've got a circle that has a radius of 8 inches. And we construct a central angle of 120 degrees. Do you remember how to calculate the length of that arc? To find the length of that arc, step 1 is to find the circumference of the whole circle. So C is equal to 2 times pi times 8, which is 16 times pi, otherwise known as 50.24 inches. Step 2. Is to apply the angle fraction. What does that mean? Well, is that circumference 50.24 times 120 over 360? So 16.75 inches is that arc length. Sector area. Do you remember how to do that? Step 1, find the circle area. Area of the circle is pi times radius squared. Otherwise known as (200.96 inches squared). Step 2. Once again, apply that angle fraction. 200.96 times 120 over 360, which is going to give us 66.99 inches squared. Is that correct? So really all that can change here is the radius, or if we're given the diameter, you could find the radius from the diameter, and that central angle. Now, as we move on, we don't know how to find this one quite yet. But as we move on, we're going to know how to find something like this. Actually, I'm going to erase that. Let's say I know that this is a diameter of the circle here. And if I tell you that that diameter equals 10 inches, and that this angle here equals 30 degrees, we will at some point be able to use that information to find the area of this whole thing. Because what we'll do, we'll be able to cut this. You know, this angle has to be what? 60 degrees. Good. So you'll be able to find the area of that sector there. So that's just a matter of this is going to be 5 and 5 here, right? This is going to be 120 degrees and 30 degrees. It's an isosceles triangle because it has 2 radii as sides. And you'd be able to go from there to find the area of that using trig. For right now, we're going to leave that as a little foreshadowing for you. Got to leave you in suspense a little bit, right? Okay, so far we've been measuring all our angles in degrees. We talked briefly about radians. Do you remember radians? No? What a radian is, I'm going to introduce you to a concept called the unit circle. The unit circle is a circle that has a radius of 1 unit. What unit? Inches, centimeters? It doesn't matter. It's just 1. So on a unit circle, this is defined to be 0 degrees is the straight east direction, right? And our angles go around it counterclockwise. So let's say that this is 45 degrees here. The radian is the length of this arc. So, again, the radius here is 1. So the circumference of the circle is 2 times pi times 1, right? So the circumference of that circle is 2 times pi. And I'm going to leave it as 2 times pi. So the whole circle would be 2 pi radians. So the circumference of the whole circle is 2 pi radians. So then to find out how many radians this 45 degrees is, it's 45 out of 360 equals how much out of 2 pi? So 45 times 2 pi is 90 pi, right? Divided by 360. And instead of actually dividing, we usually reduce the fraction. 90 and 360 both divide by 90. Give me 1 pi over 4. So you could leave it as 1 pi over 4 or just pi over 4. What's that? Yeah. So if I have something that is 2 pi over 3 radians, and I want to convert that into degrees. Well, again, I've got 2 pi over 3 over a total circle is 2 pi, right? In degrees, the total circle is 360 degrees. So this is going to be my number of degrees here. So I cross multiply and divide. 2 pi over 3 times 360. It's 2 pi over 3 times 360 over 1. I would cross cancel the 3. This is 1 and this is 120. 2 pi times 120 is 240 pi. 1 times 1 is 1, so it's 240 pi over 1. Then we've got to divide by the 2 pi. So this is 240 pi divided by 2 pi. What happens to the pi's? They divide out. 240 divided by 2 is 120. It's 120 degrees. Does that make any sense? Another way we could do it is we could use unit conversions. We know that 2 pi radians equals 360 degrees, correct? That's a full circle. So if I give you 3 pi over 4 radians, or 3/4 pi radians, and I want to change it into degrees, here's what I would do. First of all, I'm going to write this like this. I'm going to put the radians in the numerator. So it's 3 pi radians over 4, like that. Now I want to get rid of radians, don't I? I'll put radians on bottom, and I'm going to degrees, so I want degrees on top. Perfect. 2 pi radians equals 360 degrees. So I can cancel out the radians. Guess what else I can cancel? The pi's. So I've got 3 times 360, 1,080 degrees. 4 times 2 is 8. So I divide that out. Is that 270 degrees? Is that right?
No, I got 135.
That's what I thought. I was going to say, something doesn't look right there. That's 125 plus 10. 135 degrees. There we go. I was doubling up on you. 135 degrees. Or if I go the other way. Let's say I give you 30 degrees and I want to know how many radians that is. I can do the same thing. Here I'm just going to do 30 degrees over 1. So now I'm going to get rid of degrees, so I'm going to put degrees on bottom and radians on top. 2 pi radians equals 360 degrees. Now the degrees cancel out. I have 30 times 2. I could cross cancel the 30 and 60 if I wanted to. 30 and 60 both divide by what? 30. So 30 divided by 30 is 1. 360 divided by 30 is 12. So now I have 1 times 2 pi radians is 2 pi radians. On bottom I've got 1 times 12 is 12. I can still reduce the 2 and the 12 both divided by 2. So that's just pi over 6 radians. That might take some getting used to.
Yeah, but overall, I think it's kind of what we learned.
Yeah, it's similar. That's why I took so much time with those unit conversions last semester, because I know you can convert feet to inches without having to do it, but knowing that unit conversion comes in handy here. So on page 533, it's exercise 25-1. Page 537 to 539, it's exercise 25-4. Page 542 through 544, it's exercise 25-7. And finally, page 546 through 548. Exercise 25-10. Let you guys have the last 8 minutes to get started.